Hello everyone, so today I'm going to be explaining the Physics Paper 2 and it's the higher paper to you. This is a paper from June 2018 and we'll go through every single question just to make sure that you understand properly. So if we look at this first question, a student investigates acceleration using gliders on air track and light gates. The air track reduces friction between the glider and the track to zero. Figure 1 shows the apparatus, so we've got a diagram of our apparatus here. The glider was released from rest and moved along the track. The mass hit the ground. Now this is important. It hit the ground before the card passes through the second light gate. And we've got to say which two statements describe the effect this would have on the glider. So if it's going to hit the ground, then the acceleration is definitely going to reach zero. Its acceleration would increase. Well, that's incorrect. The resultant force on it would decrease to zero. If the acceleration has reached zero, then that makes sense. Let's just read the last two just to make sure they're not correct. The resultant force on it would increase, so that's not right. And its speed would increase, so that's not right either. For the second part, it says the mass holder should not hit the ground before the card passes through the second light gate. Suggest one way the student can stop this happening. So we can either say move the second light gate closer to the first, or we could say we could shorten the string length. For this next question, it says the student increased the resultant force acting on the glider by adding more masses to the mass holder. She calculated the acceleration of the glider for each resultant force. Each test was done 3 times and table 1 shows the results. So we have resultant forces at 0.2, 0.39, 0.59, 0.78 and 0.98 newtons. We have our mean acceleration calculated from the 3 tests done. It says the student made 2 mistakes in the mean acceleration column. Identify the mistakes the student made and suggest how each mistake can be corrected. So the first mistake is here. We shouldn't give a result to more than 2 significant figures because that's how we recorded our results in test 1, test 2 and test 3. And our second mistake is here because the mean calculation for the acceleration has included an anomalous result. If we have an anomalous result, it shouldn't be used in the calculation of the mean. For this last part of the question, we have to look at our results table and we have to write a conclusion for the investigation. So looking at our results table, we can see that it is a positive correlation, which means that as the resultant force is increasing, the acceleration is increasing. Now in this next question, the student used a constant resultant force to accelerate the glider. The student changed the mass on the glider and calculated the new acceleration. She repeated this for different masses of the glider, keeping the resultant force constant. And we have our results in table 2. So the question, which I've already plotted on the graph there, was to plot the results in figure 2 and draw a line of best fit. Now, once we've plotted these results, first of all, it's important to remember that all of the points have to be plotted within half a small square for you to get the marks for plotting your points. You then have to do a smooth curve of best fit. So you're not allowed to sketch, it has to be one smooth line or curve of best fit. Then we can see from the graph that for this particular set of results that the mass and acceleration are inversely proportional. So like we said, we can see from the graph that for this particular set of results, the correlation is that it's inversely proportional. As the mass increases, the acceleration decreases. For this next question, a magnet produces a magnetic field. Which diagram shows the magnetic field pattern around a magnet? So first of all, when we look at the diagrams, the correct magnetic field lines are shown by these two. However, we've got to remember that the field lines go from the north to the south. So the correct answer is this one here. Then looking at our second question, we've got figure 3, which shows 3 metal blocks. The blocks are not labelled. One is a permanent magnet, one is iron, and one is aluminium. And we've got to try and find out using another permanent magnet which block is which. So if we look at this question, using our permanent magnet, we'd be able to identify the aluminium purely because it would have no effect on the permanent magnet would have no effect on the aluminium. Then the iron would be attracted to the permanent magnet, but it would not be repelled. And thirdly, it would only be the permanent magnet that's attracted and repelled by the other permanent magnet. So let's get this down. In this next question, figure 4 shows a toy crane. It says a toy crane uses an electromagnet to pick up and move the blocks. Explain how the electromagnet is able to pick up and move the blocks. So first of all, if we turn the switch on, the switch will complete the circuit, and this would then turn on the electromagnet. And because the electromagnet is a coil of wire around an iron core, the iron core becomes magnetized because then a magnetic field is produced around the coils that's wrapped around the iron core. So if we then move the electromagnet towards the blocks, they're going to be attracted to the electromagnet, and the electromagnet is going to be able to pick them up. And then when we switch the switch here off again, then what that means is the circuit is broken, so the electromagnet is then turned off, which means there's no more attraction between the blocks and the electromagnet, and they will fall and move to the position we want to put them in. Now in this next question, it says figure 5 shows an ice skater, skater A, and we have our diagram here. It says write down the equation that links mass, momentum and velocity. So this is just recall of you knowing the equations. So the correct answer is momentum equals mass times velocity. Then skater A travels with a velocity of 3.2 meters per second and a momentum of 200 kilograms meters per second. Calculate the mass of skater A. So we have to rearrange our equation. So we have mass equals momentum divided by velocity. And if we put in our numbers, we would have 200 divided by 3.2 and 2 whole numbers. That would give us an answer of 63. Or you could put the answer of 62.5. Now in this next question, it says skater A bumps into another skater, skater B. Skater B is stationary. The skaters move off together in a straight line. Explain what happens to the velocity of each of the skaters. Use the idea of conservation of momentum. So the first thing here is that we need to explain conservation of momentum. So the total momentum before the collision should be equal to the total momentum after the collision. Now, the next key thing to remember is momentum is mass times velocity. So, what this means in terms of the velocity of the skaters is the momentum of skater A after the collision would decrease, which means the velocity of skater A would decrease. But because skater B was stationary to start with, the velocity and the momentum of skater B would increase. If we look at this next question, we've given figure 6, which is showing 4 Newton meters, and we can see that Newton meter A has a maximum extension of 2.5 newtons. We've got 5 newtons, 10 newtons, and 20 newtons. Which Newton meter has the spring with the greatest spring constant? And give a reason for your answer. So the answer here would be D, and the reason being that D needs the greatest force because it has the largest amount of force in terms of the scale to move the spring the same amount of distance. This next question, it says the Newton meter in figure 7 will give an error when used to make a measurement. So we've got to name the type of error and describe how this error will be corrected. So first of all, the error is in it not being at 0 to start with. So that's called the 0 error. And the way that we correct this is simply we just adjust the Newton meter so it starts at 0. Now, in this next question, a student hangs a weight on a Newton meter. The energy stored in the spring in the Newton meter is 4.5 times 10 to the minus 2 joules. The student then increases the weight on the Newton meter by 2 newtons. Calculate the total extension of the spring, and the spring constant is 400 newtons per meter. So, first of all, we would use an equation from the equation sheet that is given to you in the exam, and it tells you that the elastic potential energy is a half spring constant times extension squared. So putting our numbers in here, we have our elastic potential energy, which is the energy stored. So we're saying 4.5 times 10 to the minus 2 joules is 0.5 times the spring constant, which is 400, times our extension squared, and that's the initial extension that we're trying to work out. So 0.5 times 400, that would be 200 times extension squared is 4.5 times 10 to the minus 2 joules. And if I rearrange that to get extension squared, we would have 4.5 times 10 to the minus 2 divided by 200. And so to work out our extension, we would square root our answer there. And if you use your calculator to work that out, the extension would work out at 0.015 meters. However, for the next part of the question, we were told here that the student then increases the weight on the Newton meter by 2 newtons. So now we're going to have to use the second equation, which is one of the ones that we are supposed to learn, and that is that force equals the spring constant times extension. And we're told that the force is, so if I put my numbers in here, our force is 2 newtons, The spring constant is 400 times extension is what we're trying to work out. So the extension would be 2 divided by 400. And the extension, therefore, for this part works out at 0.005 meters. So we have our second extension here, and we have our first extension here. So the total extension is going to be the sum of both of those. So 0.015 plus 0.005, and that would give us an answer of 0.02 meters. So in this part of the question, we're told that a car aerial receives radio waves from a radio transmitter. Radio waves are transverse waves. Sound waves are longitudinal waves. Describe the difference between transverse waves and longitudinal waves. So we've got to talk about the vibrations compared to the direction of energy transfer. So for longitudinal waves, the vibrations are parallel to the direction of energy transfer. So that's for longitudinal waves. So you may have seen a diagram that looks like this. And then for transverse waves, the vibrations are perpendicular. That means at right angles to the direction of energy transfer. So for that one, the energy transfer is this way, and we have the waves going at right angles. And for the longitudinal waves, the direction of energy transfer is parallel. It's in the same direction as the vibrations. So for the next part of the question, we're told that radio waves have a frequency of 4.8 times 10 to the power of 9 Hertz. The wave speed of an electromagnetic wave is 3.0 times 10 to the power of 8 meters per second. And we've got to calculate the wavelength of the radio waves. And we've got to give our answer to two significant figures. So the equation that we use is wave speed is frequency times wavelength. And that therefore gives us that the wave speed, so 3.0 times 10 to the power of 8 equals the frequency, which is 4.8 times 10 to the power of 9 times our wavelength. And if we rearrange that, then that gives us the wavelength is 3.0 times 10 to the power of 8 divided by 4.8 times 10 to the power of 9. And if we calculate that out, we get an answer of 0.0625 meters. Now, the key thing now is to get that last mark, we've got to give our answer to two significant figures. Now, because the third significant figure is 5, we would round up to 0.063. And if you don't give your answer to the significant figures that's been asked for, you would lose a mark at that end part there. For this next question, we've got to describe how the radio waves reaching the car aerial produces signals in the electrical circuit of the car radio. Now, we've got to be quite precise because it's worth 3 marks. So to get the first mark, we would have to say that the car aerial is going to absorb energy from the radio waves. To get the second mark, we would need to say that the electrons in the car aerial are made to vibrate due to this. And then to get the third mark, we would say that the vibrating electrons create an alternating current in the car aerial. So in this next question, we have a graph, a distance time graph for a car travelling at 15 meters per second. And we're told that when the driver is tired, his reaction time increases from 0.5 seconds to 0.82 seconds. Determine the extra distance the car would travel before the driver starts braking. So what we can do is we can use our graph to draw our distance at 0.5 as our first time. Then if we look at that, that gives us a distance of 7.5. And if we do the same using our ruler at 0.82, so that's just one square, small square after the 0.8, and then we draw our line across. That would give us 12. We would have a look there. So we've got 10 here, we've got 15 here. So each two small squares is going to be 1. So we've got 1, 2. So we're looking at about maybe 12.3. And therefore, we would have an extra distance of 12.3 minus 7.5. And if we calculate that out, the extra distance that would be travelled is 4.8 metres. Now, for the next part of the question, it says when the brakes are used, the temperature of the brakes increases. Explain why using ideas about energy in your explanation. So, if we're looking at this question, there's going to be a decrease in kinetic energy. The movement of the energy when you apply the brakes is going to decrease. It's going to be less because you're doing work on the brakes by using friction. And this in turn, therefore, so when we're doing work by causing friction on the brakes, that increases the internal energy store or the thermal energy store of the brakes. So that would therefore increase. For this next question, it says a lorry travels 84 metres with a constant acceleration of 2 metres per second squared to reach a velocity of 19 metres per second. Calculate the initial velocity of the lorry, and we can use the physics equation sheet to help us. Now, when we look on the equation sheet, the equation that we are going to use is v squared minus u squared equals 2as. And if we input our numbers from the information given, that would give us v squared, so 19 squared minus u squared equals 2 times acceleration, which was 2, times the distance, which was 84 metres. Now, what that therefore means is that 19 squared minus u squared equals 336. So if we rearrange that, we could have u squared equals 19 squared minus 336, which means u is going to be the square root of 25. So if I calculate this part out, it ends up being 25. And the square root of 25 is 5 metres per second. Now for this next question, we've got to describe the relationship shown in figure 9, which is the graph of thinking distance, braking distance and stopping distance. And we've got to include factors which would affect the gradient of the lines. Okay, so if we look at our graph, first of all, we'll take one at a time and look and see what it is that affects these different parts. The first part that we're going to look at is to do with the thinking distance. So that's the lower graph here. And we can see that as the speed increases, the distance that the car travels before it stops also increases, so it's directly proportional. The kind of factors that will influence the thinking distance would be anything that's going to influence your reaction rate. So those would be things like the use of drugs, the use of alcohol, if the person is tired or not. Then, if we look at our second graph, which is the braking distance, we can see that as the speed increases, the distance travelled before the car actually stops when you apply your foot on the brake also increases. However, this isn't a directly proportional graph. It's increasing at a greater rate with increasing speed. And the kind of things that will influence the braking distance would be things that are to do with friction. So, for example, if you have poor brakes, when the brakes are applied to the tyre, they're not going to stop the wheels as fast as they should do. If your tyres are in a poor condition, they're not going to have as good as a grip on the road as they should do. If the roads are wet or icy, again, it's to do with the friction between the road and the tyres. And then lastly, the stopping distance is the thinking distance plus the braking distance. So it's the total of the two. And that therefore increases with speed at an increasing rate. Um, and and that's because it's the total of both of them put together. Now, in this question, we've got figure 10, which shows horizontal forces acting on a man swimming in the sea. So we have force A and force B. Describe the movement of the man when the resultant horizontal force is zero. So if his total horizontal force is zero, that means he will be moving with constant velocity. The second part of the question, it says the man increases force A. Explain what happens to force B and to the movement of the man. So if we increase force A, to start with, the man's going to start to accelerate. It's going to move faster. But then the friction will then start to increase as well until A and B are equal again. And when they're equal again, that means his resultant force is zero. So he's moving with constant velocity again, but the constant velocity now would be higher than the constant velocity before. So for this question, a boat moves through the sea. There is a 3,000 Newton force to the west of the boat. There is 1,000 force to the south of the boat. Determine the magnitude and the direction of the resultant force of the boat. And we've got to draw a vector diagram. So drawing our vectors, we can see that our resultant force is going to be a combination of the force which is due to the west of the boat and the force which is due to the south of the boat, but the scale has to be the same that we use for both of these vectors to get our resultant force. Now, to work out the resultant force, there are two ways of doing this. Either you can use this as a scale drawing, in which case, if you have an answer of 3,000 newtons, that would be allowed. Or we could use Pythagoras to work out the resultant force. And in any case, then a resultant force of anything within the range of 3,100 newtons to 3,200 newtons would be accepted. But remember, this is a vector, so then we would also have to give the direction of the resultant force. And the direction of the resultant force, if we measure it, is actually 252 degrees clockwise from north. So that's that way. And you'd be allowed an answer within the range of 251 to 253 degrees. Now, for the next question, it says the force to the south on the boat increases. What effect does this have on the resultant force of the boat? So, if the force towards the south increased, firstly, the resultant force would have a bigger size. So, the size of the resultant force would increase, and the direction that the boat is moving would change more towards the south. Okay, so that brings us to the end of the session. Well done. You've got through it all. Please do remember to subscribe. What that will do is it will give you easy access to all of the new content I'm adding on a frequent basis, including chemistry and biology papers that will be added soon.